Good afternoon to all of you. This topic is given to in this course series is geospatial approach in soil quality assessment. As we know that geospatial data are being widely being used for the mapping of various natural thematic layers and how these thematic layers can be utilized for assessing the soil quality. Today the soil quality is one of the burning topic or hot subject which soil scientists are interested or a natural resource planner or are, required to is interested to study the soil quality. What do you mean by soil quality? Actually, soil quality, as we know that quality means how it can perform, how it can do its best services. So related to the soil quality. So we would like to know that is what is it, how do we measure it, and how do we enhance it, but we are not covering on this how do we enhance it, but restricting our lecture on the what is the soil quality and how we can assess this quality. If we see the soil quality, it is a complex property, it is not a single attribute or single characteristics is required to study. Here you can see the soil quality is a function of physical properties, a physical function of the soil factors, chemical factors and biological, because we understand that soil is a dynamic body and it is characterized by its physical properties, chemical properties and biological property. So these factors affect the environment quality. So soil quality is related to our environment quality and in which it affects directly and it affects indirectly about water quality, air quality and soil quality. In water quality, it purifies water for us. Air quality, when suspended sediments remain less in the air, for example, in the arid and semi-arid region, in the month of May and June, we see air quality deteriorated, and it is directly related with your soil, governed by the soil. And this air quality, soil quality is related with our agricultural sustainability. If we want to assess that the particular land use system is sustainable or not sustainable, we want to study the soil quality. If soil quality is getting deteriorated over the period of time when we are using the land under a particular land use, then we can say it is the land use or the practice is not sustainable. Sustainable, how we can assess that one? Sustainability can be assessed with the economic sustainability. Sometimes farmers is growing crop, but economically it is not sustainable, or he is not getting profit per hectare of his land, or what is the land units he is having. So economically it is not viable. So and then it comes that is the social variability. Because of that, it also affects our societal variation, because if your land is getting deteriorated, so in that area some farmers lands are good, but some are getting poor yield, and that's resulting the social variations in the area. And then comes the environmental quality. Sometimes we are getting very good yield from the particular land use or particular crop, but it is affecting our environment. For example, we are incorporating more and more fertilizer to the soil and we are getting good yield, but at the same time the residue, the fertilizer, some nutrients go into the groundwater. As we know, that is nitrates go to the groundwater, or sometimes in the heavy the pesticides we are applying in the field, and that is heavy metals or pesticides go to our water bodies because of surface runoff or because of the movement into the soil. So it is affecting our environmental quality. So we consider soil quality is related with our environmental quality, it is related with our agriculture sustainability. So before we switch over to how to assess the soil quality or which factors are there, here I will like to tell that if we see the land and we consider what are the components of the land, then we come to know that the land is comprised of climate, geology, topography, soils, hydrology and vegetation. So soil is one of the component of land, and here we are going to assess the soil quality, one component of the land. But if you want to assess the land quality, then in this you will integrate the along with the soil quality, you have to also assess your climate, you have to assess your geology, you have to assess your terrain, you have to assess your water or hydrology, and you have to assess your vegetation, means degradation of vegetation. So integrating all these, you can assess the land quality, which is more related to environmental quality. But in this lecture series, I am discussing only the soil quality. Land is a wider term, and soil is one of the component of that. So first of all, to study the land quality, we need or soil quality, we need to identification of area of land which is uniform. We map an area which is uniform in terms of the land quality characteristics or land quality elements. So this one was discussed in my previous lecture when I discussed use of remote sensing in GIS in soil resource mapping. While doing the soil resource mapping, our purpose is to delineate a homogeneous land unit area which is similar in soil forming factors. And soil forming factors is nothing but you can say it leads to the delineation of area which is uniform. So this is the prerequisite for your soil quality assessment. You need a soil map, or you need a soil boundaries, or you need a physiographic map which will guide you where to collect the soil samples. And then we study that soil in detail in this lecture. Such areas sometimes we call that is physiographic unit, which I told you. And for studying, we used to study the characteristics, land characteristics, we used to study the soil characteristics, because land quality is also a complex attribute. Soil quality is also a complex attribute. So complex attribute is composed of many attributes. As land quality or land is comprised of the various land characteristics. For example, if you talk about the terrain, then it is the slope. If you talk about the rainfall and climate, then it is rainfall and temperature. If you talk about the soil, then it is primarily soil texture and soil depth. So these are the factors we need to study while we want to study the soil quality or land quality. Then first, here in this lecture we are focusing on the soil quality, and we can see a soil quality is a complex characteristics. You cannot measure soil quality directly, because soil quality is a complex characteristics of land which has well understood influenced by the capability of land for a specific use. So to study the soil quality, you have to study the individual soil characteristics. For example, individual soil characteristics is availability of soil moisture for plant growth, erosion, and the ability of soil to retain nutrients, or how much nutrients present into the soils. Although a soil quality may be measured or calculated, because soil quality cannot be measured directly, it is measured indirectly with the composition of or with the consideration of many soil parameters. One word is also very common, that is soil health. Soil health, soil quality are used synonymously. Means if sometimes we are calling it is a soil health assessment or soil quality assessment. Soil quality gives greater emphasis on soil biodiversity, ecological function, and that makes soil a dynamic living resource with capacity of self-organization. So I can say the soil quality itself is a wider term and it is affected by various parameters of the soil. So, what is the soil quality? What we can define it? Soil quality is the capacity of a specific kind of soil to function. Then means soil quality is related with quantified or is related with the soil to function within natural or managed ecosystem. Means soil quality is more relevant with your managed ecosystem means agriculture fields. But in natural system also we are used to assess the soil quality. For example, forest area, plantation area, where there is a natural vegetations are existing. That quality is there. What quality is there? We need to study. Why soil quality? What it gives you? Soil quality provide informations to sustain plant and animal productivity. What the vegetation you are growing, is it productive or not? Or animal productivity, means your animal's health or animal products quality will depends how the soil quality is there. If your soil having a lot of nutrients, a good amount of nutrients, then fodder and grasses grown over that and which is being consumed by the animal, then you will get the animal having nutrients in their meat. So that's why your product or your milk product, its nutrients, more nutrients will depends on what your animal is taking or eating. So sustain the plant and animal productivity, your soil quality affects that one. Second is to maintain or enhance water and air quality. Soil quality is related with our water quality because suppose soil erosion is taking place and because of erosion we know the fine soil particles are removed from the soil surface and where it will go? It will go to the water body. So it pollutes or sediment, it pollutes your water and that's why there not only the sediment is going but also there the nutrients are going and nutrients and sometimes your pesticides which you have applied over the field that is also washing out from the agriculture field area and going to your water body, for example river or dam or from the where water you are consuming. That's why it is enhancing, or if your soil is good or soil is doing its duty, then you can get a good water, otherwise your water will be polluted. Air quality means from the arid and semi-arid area that we know that sediments go into the air and fine sediments and then you are getting in the summer season that is lot of dust and fine particles in the as a aerosol in the atmosphere. So it is affecting the air quality. In the arid area or in the African countries, air quality is one of the most important problem and that is governed by the soil quality. Because if you want to improve the air quality, then you have to take into account that is the soil quality there. This last you can say soil quality support human health and habitation, because we know human health means what the wheat you are food grains you are consuming, if they are being grown in the balanced nutrients condition, then your grains having good amount of nutrients. Otherwise, these are the deficient of nutrients when we are consuming over long period of time, then it will affect our health. That's why soil quality is related with the human health. In case of habitations, we can take the example, suppose your area is a waterlogged area, degradation has taken place and or some other because of other effluents from the industrial sectors, if that is collected over the surface of the soil, then it is affecting your habitation or settlement. So it is also soil quality affecting your habitation. Then we need to find out what are the major function of the soils. The soils having mainly five functions. First, we can say sustain biological diversity. If soils are varying type, it is nutritious, quality is good, then different kind of microorganism, flora and fauna will be existing and its activity will be in good shape and the soils will be productive. Second is regulate and partition water and solute flow. If your soil is good of quality, then it will allow infiltration of water into the soil and then solute flow or the solute or nutrients flow within the soil surface will take place. And so it is soil is regulating the water flow into the our cycle or into the system. Third is filter and buffer. Soil act as a filter and act as a buffer to buffer and degrade it, degrade, immobilize or detoxify organic matter, organic minerals, because many of the, suppose you are putting the sewage or effluent water from the factories or from the water from the nala, those things, what soil is working as a filter, fine filter, and it absorbs the pesticides or other nutrients or other materials, organic residues within the system and allow water to move into the groundwater. That's why we say that is the groundwater is fresh groundwater, or groundwater you find a very with less impurities or very few impurities. So it is doing a filtering, and can you think that if filter it doesn't work as a filter, then your surface body will be polluted. Fourth is store and cycle nutrients. It is a soil is an important part, take parts in the cycling of the nutrients, because we know that is it absorbs the nutrients, grow well the plant, and then plant you take the grains and the residue materials go into the soils again, and then it decomposed and the nutrients are released into the soil. Then again plants take and you take as a food grain, and then again it crop residue die and it goes into the soil. So it works as a cycling of soil nutrients and carbon, because the carbon cycling, because of photosynthesis, plants take the CO2 and CO2 is released from the soil also. We call it is a soil respiration. So total nutrient cycling is governed by your soil and plant, and soil is one of the most important constituents in that one. Then last one, provide the physical stability and support for plants or socio-economic structure, or it is means soil is the supporting your socio-economic structure, building and other thing. You see that is shown in a pictorial form. It is soil is a medium for plant growth. It supplies the water supply and purification. It is doing the filtering, and through evaporation it is going to the atmosphere, doing the water cycle. It is recycling of the nutrients, habitat for the many organisms and habitat for we people, or it is the medium of engineering medium. And we know the soil is used as a brick kilns and other engineering measures, so it provides the support for that purpose. Soil quality. When we want to study the soil quality, then we have to study that there are two types of soil quality is there. One is inherent soil quality, and another is dynamic soil quality. What is difference in that one? Inherent soil quality is a soil's natural ability to function. Every soil has its natural ability to provide the nutrients, to do the filtering, to support the building structure. You know, sandy soils, which is draining faster than clay soils. So if sandy soils are there, there is a better filtering of that one. And clay soils, water do not percolate down. So deep soils, shallow soils, it affects these are the factors which is affecting your inherent soil quality. It is governed by the geology of the rock or geology of the bedrock from where the soil has been developed. So in the in situ soils, but in the transported soils, if soils is transported in the like alluvial plains, then from which type of material has been transported in that plane. So the quality of that one or nutrients present into the soils will depend the material is brought from where or brought from which type of rocks. So that's why that is the alluvial plain formed by the Ganga alluvial plain and by the Yamuna alluvial plain or Ghaghar river plain. So all the soil is brought from a different type of places having rocks and geology. So the soil is also changed. So that is related with the inherent soil quality. Another is the dynamic soil quality. Is how the soil changes depends on how it is managed. Means when we are doing the agriculture, afforestation, plantation, we are using the land for various purposes, and because of that one, it is affecting your the soil quality. For example, if you are growing the orchard, then organic matter will be more. If you are growing the agriculture, organic matter will be less. Then it affects the soil structure. Means how the soil structures means it affects the soil depth, water, nutrient holding capacity. So these are the dynamic soil quality. So when we are want to study, that is, I want to study the soil quality get affected from this use. Suppose you are doing plantation, you have continuous plantation or continuous agriculture, or you are taking one type of crops, for example, rice wheat, and if you are taking another crop, maize wheat, and if you are taking leguminous crop and then grain crop in combination, then how the soil quality changes? That comes under the dynamic soil quality, because farmers are using the land in various uses and from the various years, many years, but their management is affecting our soil quality. And if we want to study that one, then we have to study the dynamic soil quality. But if you want to study the potential of the soil, then you have to go to study the inherent soil quality. So for the depends on the purpose which soil quality we want to study, and then we select the soil characteristics. Here you see the soil quality is linked to the sustainability. As I told you, suppose farmers is using for particular land use system. One means he is using, suppose, the rice wheat cropping system. He is using for rice sugarcane cropping system. One is using legume crop or pulses plus grain combination system. Then this system is sustainable or not sustainable? It will remain sustainable for future or not? If we want to study that one, then we have to study its soil quality. And then if soil quality is improving, then you can say that it is related with the sustainability, or this land use systems will remain sustainable in future also. Otherwise, its sustainability is, if it is soil quality is poor, then you can say this land use system is not sustainable. So, if you want to, by monitoring the change in soil quality, because you take every 5 years sample and you measure some of the soil properties, and then you are finding, yes, this is there is an improvement in soil properties or there is a deterioration in soil properties. So you can link with the soil, then you can monitor the soil quality in that area. Assessing the soil quality. Now comes, that is, soil quality assessment is the process of measuring the management induced changes in soils as we attempt to get soil to do what we want it to do. So means soil quality assessment is the process of measuring the management and management induced changes, means because of management which properties of the soils is getting affected, that we need to study. Soil quality cannot be measured directly. When we cannot measure directly, means we cannot study directly with the remote sensing data. It is not a property of only one factor. It is property of many factors. So just because of the reflectance properties of the soils, you cannot decide this is the soil quality, what is the soil quality is there. So one thing you should keep into mind, that remote sensing directly cannot be used, but indirectly various parameters or various soil attributes information can be get from the remote sensing data, which can help you in assessing the soil quality. Then questions comes, which should be the indicators we should take into account for assessing the soil quality. So indicators can be a physical properties, chemical properties, or biological properties. But these indicators should be easy to measure. We should not take those indicators which are very complicated, very complex, and very expensive to measure. So that cannot be an indicator. Indicator should be easy to measure, and it should measure the changes in soil function. If function is changing, then soil quality, soil parameters or that properties should be easily changed so that we can see the effect of that one. It can be a combination of physical, chemical, and biological all properties. It should be accessible to many users, applicable to field conditions. Means that is, many users can know about that properties. We cannot make a very complicated properties which other users are not able to get that one. We should able to correlate well with the ecosystem process. Means properties should be such that it can be correlated with what you are doing on that land or ecosystem process. For example, suppose you say the soil pH. Soil pH is one of the most important indicator for the assessing the soil quality. Suppose pH and organic carbon is also one of the most important parameter. You say organic carbon is increasing with the ecosystem, then you can ecosystem process. For example, you are taking the irrigated, unirrigated, you are taking the forest orchard, you are taking the mixed cropping. So with that one you can correlate with that one content of that parameter. And this is the soil quality is also used to study the climate change, or the properties should be selected in such a way that it should be sensitive to variation in climate and management. What are the indicators then? The indicators which has been published in the literatures, they are most important indicators is soil organic matter. And soil organic matter, which is related with the soil fertility, related with the nutrients present into the soil, and it is also related to the soil erosion. And if suppose you want to study only one factor, one properties to assess the soil quality, you can take soil organic matter, that one. Otherwise, physical factors. Which are the physical factors? Soil structure, depth of the soils, infiltration and bulk density, water holding capacity. These are the properties we can measure with in the soil, or we collect the soils. Suppose you go to the soils, you can see the soil structure. What is the structure? It is the arrangement of the soil particles. So in the manuals it has been described how you can find out the structure. If structure is granular structure or subangular blocky, we suppose it is good structure. But if it is platy or some other type of structure, it is not good one. Depth of the soils, we know if depth is more, then soil quality will be more. Infiltration and bulk density. If infiltration is high or moderate, then we can say the soil will perform good, or it is good one. But if infiltration is less, then it is not good one. Water holding capacity. How much water is able to hold that one soil? You know, if holding is more, then it can support more water to the plant. So we measure the water holding capacity of the various type of soils. And how this is being related with the soil health and soil quality, you see, it is related with the nutrients, it is related with the habitat of microbes, it is related with the water movement, in, for example, infiltration rate, and water holding capacity, it is related with the workability. Suppose a soil of clay in nature will have the high water holding capacity. But if clay is more, you cannot use for building structure, or if you are using for building, then you have to take the extra care for that one. So in this case, for example, black soils in India, where high clay content is there, and that soils are having high water holding capacity. So in the seasons, they have swell and sink capacity. So workability is very poor. So it is not good for the building structure. If you are making the building, then you have to take extra precaution. Chemical property, pH, electrical conductivity means salt concentration, extractable sodium, nitrogen, phosphorus, potassium. This is important for the plant growth. So pH and how much pH, acidic pH, basic pH or neutral. Generally soils we require the neutral pH. So away from the pH is one of the most important indicator. Electrical conductivity, salt concentration it indicates. Biological properties, because soil is a biological, we say it is a natural and dynamic body, and there are a lot of microbes remain. If soil is having good amount of microbes, then we say the soil is having high quality. Why? Because microbes are responsible for your release of the nutrients into the soils. Suppose if microbes were not there, if the residue are falls on the ground, then they will not decompose. And if it is not decomposed, then how the nutrients will be released to the soil system? And if it is not released to the nutrients, are not released to the soil, then your plant cannot take. So that's why microbes are very important. And but you should know that is where microbes are there. So biological properties, we study how much microbes are there, what is population there. Sometimes we study with the help of the carbon nitrogen ratio. We also study how much mineralizable nitrogen is there. Means because of mineralization the process, microbes release the nitrogen into the soil. We also study the soil respiration. You know, from the soil respiration, CO2 is released. But who is doing soil respiration? Because microbes present into the soils is indicating that is your soil respiration. So soil respiration is a direct indicator of the total microbes present into the soils. If respiration is high, then we can say this is soil quality is good. So there are various instrumentation are available in the soil laboratory where we use the instrument to measure biological properties, to measure chemical properties, to measure physical properties, and then combination of these properties all together we use to help, that is to study the soil quality of the soil. Then we see that is the which are the properties are there. Then you see here relatively simple indicators or simple properties which can be used by many of the people, but some of the properties which are very difficult, which is you need a very specialized instrumentation, or you have to spend more, or many of the soil laboratory do not have this facility to measure this one. For example, simple one, pH. We can measure with pH meter, EC meter, electrical conductivity, bulk density. You can take a soil samples, you can dry, and you can make out the density. So bulk density, depth of the soils in the field you can measure. Texture, it is sandy, clay or sandy loam, different textures. By field method also we can measure. Water holding capacity, it depends on the how much organic matter and clay particle is there. Sometimes water holding capacity we can assess with the help of depth, texture, and your with these two parameters we can calculate this one WSC. And extractable nitrogen, phosphorus, potassium, you know the primary nutrients which is there, nitrogen, phosphorus, potassium, which we need to measure to assess the soil quality. But the difficult one is that soil organic matter, total SOM, active organic matter, nitrogen mineralization, microbial biomass, microbial diversity, different type of microbes. It is very difficult, you need a specialized facility for that one. So you see the soil quality monitoring tool. For the soil quality assessment, first requirement is that you have to do intensive sampling. You have to take a very good amount of soil samples. Otherwise, you with one or two or few samples, you cannot say that is my soil quality is what. The second is all the analysis which I told you, physical, chemical and biological property, they are expensive analysis. You have to analyze your soils for those characteristics. We have the field test kit? No. Field test kits are available for few properties. For example, bulk density, soil depth, collecting the soil samples, collecting the organic matter content, pH, EC measurements you can do in the field test, but other properties you need a full-fledged laboratory where you can analyze those properties. So just I will show you here the properties, physical, chemical and biological, and this we need which instrument. For example, infiltration rate, you need double ring infiltrometer. Bulk density, you need your soil core sampler. Available water capacity, you can measure with the help of equations. Drainage, field observation. Soil structure, field observation. Aggregate stability or soil structure, we need other apparatus. Soil texture, hydrometer method. Then pH meter, EC meter, soil organic carbon, TOC, CH analyzer. So, earthworm by field analysis using mustard solution, respiration, you can need a very costly instruments to measure the soil respiration, microbial biomass. So, lot of instrumentation are required to assess the soil quality. So how when once you measure the soil quality, soil characteristics, for example, physical characteristics, chemical characteristics, biological characteristics, you have selected based on your management goal, you have collected the soil samples and you have measured these characteristics. Then we need how to compile those information, how to assess the soil quality. In general, the most commonly used the formula given by the Carlin in 2003, that is scoring function. You can measure the soil quality index. How to calculate the soil quality index? Then, first of all, as I told you, we go for the intensive soil sampling, and you have collected and you have analyzed the various soil properties. Now I want to know which properties are required to assess that one. So we go for the minimum data set selection. How you have suppose 20 properties, but all 20 properties I cannot take into account. So out of 20 properties, I will study that which one is 4, 5 or 10 properties, which is the most important one. I only use those properties. Before without in very beginning we cannot decide that I can take minimum 4 or 5 properties. We can do also, but in general, if you want to study a very good study, then you have to study all the properties and then you go to select the minimum data set. How to select the minimum data set? Because all the properties I cannot take into account, so reduce the data redundancy. And then it maximally, how to reduce the data redundancy? We can use the analytical hierarchy process, AHP techniques. We can use the component analysis techniques which will be applied, and then we can reduce that. Out of 20 parameters, only 5 or 6 these parameters are most important in that particular type of land use system, in land area. What is the AHP, analytical hierarchy process? We know that this is a pairwise comparison we used to make, and then we experts give that is the scaling, that is this property is affecting the most one. Another technique we use the principal component analysis techniques, which creates uncorrelated values, and then we find out this is the parameters which is the highly uncorrelated, and that can be used for the assessing the soil quality. If it is suppose two properties are correlated, then if you are both your properties you are using for the soil quality assessment, then it is giving only the more properties, but it is not giving the newer information. That's why we want those properties which is not related to each other. So that's why we do the principal component analysis. How we assess the soil quality? The formula is given. Soil quality index is summation of all properties. Suppose I1 properties to n properties. You can take, because minimum data set selections, we have decided that out of 20 properties, only these 10 properties are related with the soil quality, affecting the soil quality in our area much more. For example, one characteristic is important in one land use system, but that properties cannot be important for another land use system, is another area. For one area and one type of management system or one land use land cover, one particular set of characteristics are important. Here, then we give weightage of that one. For each characteristics, we give weightage, and then we give the score. Q means score. How you are giving the weightage? Weightage is given with the help of the AHP, analytical hierarchy process. We give the, so for example, weightage. Suppose I am giving the weightage maximum to the organic matter, second pH, third texture, fourth soil depth. Like that we give the weightage, and weightage is given from 0.1 to, you can say, the 1 0 to 1 in scaling weightage is given. Then Q is the score value, and score value is Q is the indicator scores, and we give the score, for example, in relation with the what is the optimum. For example, the good pH is 7.0. If you are getting pH 6.5 or you are getting 8.5, then you divide with the pH 7, divide 7.0 and you rescale into 0 to 1 value. So we scale the properties and give the value, so 0 to 1 Q and weightage 0 to 1, and our properties are make the summation, and then we get the soil quality index. So this is the one of the technique how you can size this total soil quality assessment. Field survey for ground data collection. So we have to do an intensive field survey to collect the samples. Then question comes, what depth of the samples should be collected? Depth should be 0 to 25 centimeter top and 25 to 50 centimeter. So we take into account up to the 0 to 50 centimeter because that is the layer which is responsible for the plant root development in general in agriculture field. But if you are taking in the forestry or other area, then you have to say the roots, most of the roots are concentrated at which depth. So according to that we collect the soil sample. You are doing the soil sampling, then brings the soils for the lab analysis. Then you have measured the various properties of the soils. For example, you have analyzed all physical, chemical and biological which are the most important, and then you are saying that there are 20 characteristics are there. Then you have to select which are the minimum data set, means in your area which properties are varying lot. Standard deviation is more. If some properties, suppose you are saying this is not changing much in my area, it means that properties has not variation. So that properties cannot be taken into account for the soil quality assessment. So that's why we, out of 20 properties or many properties, we select the minimum data set. And how we can do that one? We can do by principal component analysis, we can do by the analytical hierarchy process. Then we select the indicators. These are the indicators or these are the properties which is useful for our soil quality assessment. Then for those properties, then you give the weightage, you assign the score using the weightage you can give with the analytical hierarchy process, and scoring we can give by the seeing its properties or its with the maximum optimum value of that properties, and then you are getting W and S value, and then for each soil we calculate the quality, each point we calculate the soil quality, and then we sum up or make average of that one to assess the soil quality for that land area. So assignment of the scores as I have discussed, and the weightage of by the AHP method. When you are assigning the scores, scoring was done on the basis of the importance of the parameter. Some parameters are better if they are more in soil, and some are better if they are less in soil. For example, soil pH. If it is more, it is not good. If it is less, then it is good but not so less. So suppose neutral pH is good one. But for example, organic matter, if it is more, it is good. But if it is less, it is not good. So some properties required in more amount, its value should be more amount, and some properties we require its value should be less amount. So we make it scoring in a very judicious way and give the scores based on our knowledge and based on the properties for the optimal requirement is there. Then we assign the weightage for the various properties with the AHP. Here I am showing you example, that is the one hilly area in Tehri districts of Uttaranchal. This is the satellite data. Here you are getting the forest area, and these are the you are getting cyan color. This is agricultural land, and this is the water body, means Tehri Dam area water body, and this is one of the water set, and we want to study the soil quality in this water set. So how we do is, this is showing the digital elevation model DEM. Here it is the lowest elevation and this is the highest elevation. So you see the highest elevation area is under the forest and this area is under the agriculture. And my objective was to assess the soil quality in agricultural land in the water set. This is the drainage map of that area, and you see I can generate the landform map with the help of digital elevation model. And you know that this is this color, cyan color, is showing the valley. So these are the valley area. This yellow color is showing the lower slope, then mid slope and higher slope. So I want to study the soil quality in valley, soil quality in lower slope or mid slope. Then I told you where to take the soil sample in your area. Then first we have to prepare the physiographic soil map. And earlier I have discussed with you, that is how to prepare the physiographic soil map. This is prepared by the visual interpretation of satellite data, considering the landform, vegetation and topography. And then we divide the area into the various units having the similar soil forming factors. And so it is interpreted that is the hilly area with moderate sloping with agriculture, hill area moderate sloping with the mixed forest. So it is, and now this yellow color you saw, this is a hill with moderate sloping agricultural land. So this is the agriculture area, this is the forest area, like that you have divided that into, and now you go for the soil sample. Here it is red color, it is spots are there. We have collected the samples from the various land use systems, and how much samples we have collected? We have collected around 50 samples and 50 subsurface samples in the various various physiographic map units. Then in some of the areas, suppose S31, we have calculated the many soil samples. It depends which land units having more area, then you can collect the soil samples accordingly. Then we have measured the various soil properties. For example, soil parameters: organic carbon, nitrogen, depth, pH, silt, clay, bulk density, coarse fragment, C, cation exchange capacity, potassium, sulfur, aggregate stability. And the weights we have find out with the help of the AHP, analytical hierarchy process. This is the weight. So weight has been assigned, and for that properties we have given the score also. So score for the general score means which quality should be good for the agriculture purpose. And then score and weight, and all the properties, 12 properties we have taken. So 12 scores are there, and I show you the formula sigma Wi into Si. So weightage and scores were multiplied, make the summation. For valley area, I have taken the 10 samples and get the soil quality index 0.71. And when I calculated for the mid slope, then the value was coming 0.5. So I can say the lower slopes having poor quality as compared to the valley area. So the various indicators can be used, and then we can composite index, soil quality index can be calculated. Now I can say the soil quality assessment in present day is very hot topic, and people want, and governments and other organizations want to know what is the soil quality, because soil quality is related with your sustainability of the land use system. So the present land use system, how the farmers are using or what the land use is going on, this land use is sustainable for future or not. To assess the sustainability, we can assess with the help of the soil quality. And at the end I can say that is, we have the handful of soils for our survival. We need to husband it, and it will grow our food, our fuel, our shelter, and surround us with beauty. If you abuse it, it will collapse and die, taking man with it. It was written in Earthveda in 1500 BC. So soil is as a human being is worried about its human health, human quality of life. We also are worried about the soil health, soil quality, how we are using the presently, how its quality is there. So quality need to be assessed regularly, need to monitor so that we can see our natural resources will sustain for the future generation or not. Thank you very much.